we are going to discuss how electrolysis systems work when we use reactive electrodes. The heading says electrolysis of aqueous solutions using reactive electrodes. Any electrode other than graphite, you can say carbon electrodes as well. Any electrode other than graphite, you must remember this, graphite and platinum, any electrode other than graphite and platinum is considered as a reactive electrode. When a reactive electrode is used for electrolysis, always the anode dissolves. The anode participates in the anode half reaction, releasing electrons, at the same time dissolving to the electrolyte. What I mean is this, just look at this diagram. If this is a reactive electrode, this is the electrode, this is a solution level. When you start the electrolysis, you can see the size of the electrode decreasing a little bit below the solution level. Why is it happening so? Because anode is going to dissolve. To dissolve, some reaction should happen. You know, at the anode always oxidation reaction occurs. Here what happens is, if you use copper as anode, here we have copper to copper solid. Copper solid will lose electrons. Each atom will lose 2 electrons and become Cu2+. This is aqueous. Silver as anode. If you use silver, then silver solid will go to silver plus, aqueous, and electrons. If you use iron as cathode, anode, then Fe2 plus changes to Fe changes to Fe2 plus in aqueous form because it is able to give 2 electrons. This is how reactions happen. In order to discuss the electrolysis of copper-2 sulfate solution using copper electrodes, as usual, I had to start the work with the electrolysis system. I can take a beaker for this purpose. And the beaker can be filled with some copper sulfate solution. It's a deformed beaker. Shape is a little bit different. Here, this is solution, copper sulfate solution. And you connect a battery to this through electrodes, but this time I'm telling electrodes are copper. Copper electrodes are reddish. This is one electrode. This is another electrode. All right. Shall you label this? I'll magnify this a little bit. Yeah, that's better. We have positive charge terminal here on the left-hand side. So on the right-hand side, we have a negative terminal, negatively charged electrode, because it's connected to negative terminal of the DC source. So on the left-hand side, we have anode. On the right-hand side, we have cathode. What are the ions present in the solution? We have Cu2 plus. I'll write them outside. The type of ions present in the system: copper 2 plus. It's too big, isn't it? I'll write the ions present in the system. Copper 2 plus, SO4 2 minus, H plus, OH minus. These are the ions. What ions are going towards the cathode and anode? If we see copper 2 plus ions, hydrogen ions, they go towards the cathode. And then, same as any other electrolysis system, sulphate ions, OH negative ions. They are anions. These ions go to the anode. Okay. We know the ions traveling towards the anode and cathode now. And then we can talk about the reactions happening at the anode. We'll go to the anode reaction. Let me take this to the middle of the page. So I can write anode reactions on the left-hand side, cathode reactions on the right-hand side, and overall reaction can be written at the bottom. Anode. At the anode reaction, oxidation reaction happens. Anode reaction. You have to remember this. Now, what are these anode and cathodes made up of? Anode is copper. Cathode is copper. If you use copper as the anode, copper anode is reactive. Copper anode is reactive means copper anode is going to dissolve. Always remember, for the anode reaction, copper electrode is going to dissolve. It happens according to the equation, copper solid giving out 2 electrons and copper. This becomes copper aqueous. Anode reaction. I told that I'm going to write the cathode reaction on the right-hand side. No, I'll write cathode reaction also on the left-hand side. Cathode reaction. For the cathode reaction, cations pass away. There are 2 types of cations, copper 2 plus and H plus ions. Both will go to the cathode, but what will react? For the cathode reaction, we have to see the cation produced by a lower reactive element from copper 2 plus and H2 plus. So what is lower reactive, copper or hydrogen? Copper is lower reactive. If copper is lower reactive, then Cu2 plus 2 electrons produce Cu, aqueous solid. We have an anode reaction, we have a cathode reaction. If you want to see what the overall equation is, I can see for the overall equation. No overall equation. What is the meaning of no overall equation? If you construct the
everything gets cancelled, sir.
Everything gets cancelled. So you don't have anything remaining in the ionic equation, in overall equation. So everything goes out. Now, does it mean that there's no reaction happening? No, there is a reaction happening. But why there's no overall reaction? It's because of this. I'll take the same equation, same diagram for the further discussion. Okay, like this. I'll try to remove this arrows. Let's try to find out what happens in terms of, changes in the solution as the electrolysis occurs. We have the copper anode. Anode is on the left-hand side. Copper anode. Because copper anode is reactive, what happens to copper anode? It is going to dissolve. I'll increase this a little bit so we can see clearly. If the anode is going to dissolve, the size of the anode will little by little go down. The size of the electrode will decrease. When the size of the anode decreases, on the cathode, the size increases. See, little by little, size of the cathode increases and size of the anode decreases. That's because we have considered the reactions earlier for the anode. Copper react giving copper 2 plus 2 electrons. Now the electrons which are produced here, electrons which are produced at the anode, through the circuit, they go to the cathode side. And then actually from here, there are copper here, copper particles. They will go to the solution as copper 2 plus. Copper 2 plus. From the solution, copper will go to the electrode and deposit. So the copper ions which are coming to the solution are going back onto another electrode. Therefore, no changes happening to the electrolyte system. And we can't write overall equation also because everything is going to get dissolved on the anode side. And on the cathode side, whatever that dissolves, it will deposit on the cathode. That's about the overall equation. So this electrolysis is quite different to other electrolysis systems because of the deposition of a substance happening on the cathode. And also anode is dissolving. Anode dissolving is the most significant feature in electrolysis system done using reactive electrodes. This part shows you what happens in this electrolysis cell. Electrolysis of copper to sulphate solution using copper electrodes. Copper anode is reactive, what I explained to you. Copper electrode is reactive. It participates in the anode half reaction. Where's the anode half reaction? Given down there, here. Anode half reaction. The electrolyte is aqueous. There are OH negative and H plus in the solution. Coming from water, okay? Now, copper 2 plus ions and H plus ions travel towards the cathode, but copper 2 plus ions react at the cathode because copper is less reactive. OH minus and sulfate ions go towards the anode, but none of the two ions can react at the anode because the copper electrode is reactive. Hence, copper electrode dissolves gradually. Equation is given. So this is at the beginning. Here you can see after some time. After some time, we can see cathode size increases. Cathode size increases. Here, anode size decreases. Anode size decreases. I'll give you a couple of minutes to find out the answers for these things. See if you can get the answers. Shall we see the answers now? I hope you have written the answers. You can compare with the answer with my answers. Ions present in the electrolyte. Ions present in the electrolyte. Yeah, it's copper sulphate solution. So we have Cu2 plus, SO42 minus, H plus, OH minus. Ions that travel towards the anode, SO42 minus, OH minus. Ions that travel towards cathode are H plus, Cu2 plus. Ions that get liberated at the anode, no, nothing. Cathode, Cu2 plus. Half reaction that occurs at anode is copper, solid, giving copper 2 plus 2 electrons. This is aqueous. For the cathode reaction, we can see copper 2 plus, aqueous, react with 2 electrons to give copper solid. Overall reaction for this electrolysis, without wasting much time, I will write an overall reaction equation. Cannot be constructed. Because all the species cancel out. Observation at anode. Anode dissolves gradually. The mass of the cathode. The mass of the cathode increases gradually. Changes that occur in the electrolyte as the electrolysis proceeds. No changes. No changes because when copper ions react at the cathode, when copper ions react at the cathode by depositing copper metal changes to, we can say, copper atoms. Copper atoms change to copper 2 ions at the anode. So with that question, we can complete the electrolysis of copper sulphate solution using copper electrodes. And using this information into, taking this into consideration, we have to discuss some of the lesson on the electrolysis, and it is called electroplating, plus there are some of the uses also.